Hello people. So this is Jai. I welcome you all to the Gurukula. So here in this channel for the next few days we are going to upload the videos that is covering the concepts from wireless communication. So today in this video we are going to see an introduction to wireless communication and certain basic terms which you will come across very often when you study the subject wireless communication. So this is a very introductory level video. So which covers introduction to wireless communications and certain terms that is related to wireless communication. So once you like this video, press the like button, and you press unlike button if you don't like the video. So I will take that as a feedback and then I will try to improve myself. And please do subscribe and press the bell icons so that you will get an instant notification whenever I post a video here in this channel. So without any further delay, let us get into the topic right away now. Okay, to start off from wireless communications in ancient period. So we could always see that communication has happened from day one of this world. So people used to communicate, but only the forms have get changed. So in ancient communication, the people were using the column of smokes to communicate. And later on, once the scripts have been invented, the people have wrote certain messages on paper and then they sent the messages over pigeons or dove. So this would be the ancient communication happening, and possibly I would say that the first communication that occurred in world is wireless communication, because these modes of communication does not require any wires to transmit the messages, the column of smoke or the pigeon. So now the modern era of wireless communication, we are living in the wireless era of communication, where most of the devices and most of the communications have become, at least the front end communication have become wireless. So this picture could possibly depict what we are going nowadays. And then the earlier technology was have been taken out, and most of the wireless communications are developed over a period of time. So to consider an example, so this is an example which we could realize that wired communication, your Ethernet cable have been replaced by your Wi-Fi router and your mobile phone charging. So earlier it was wired charging, and nowadays mobile phones comes with wireless charging, and moreover your headsets as well. So these are the few examples which we can see that the development of wireless, the area of wireless in the day-to-day usage of a common man. So here in this discussion, we will be always considering the mobile communication area. The most of the topics that we deal here and we discuss here will be correlated along with the mobile communication, mobile phones communication. So to get into the wireless communication, so we will see by definition, wireless communication is the transfer of information or power between two points or more that are not connected by an electrical conductor. Here electrical conductor, I mean the wires. So when you could able to transmit a message or transfer a message or signal from one point to other point without any physical wires, then we could say that it is wireless communication. So now let us see what are all the key components that is involved in sending a message from one point to the other point. And here, for the sake of simplicity, I will assume that the message that we are going to transmit is already generated and it is already pre-processed, and now it is ready to transmit. So based on this assumption, let us get into the components, what are all the required for wireless communication. So let us see. Yes, of course, I need a transmitter. So transmitter, we will be sending a messages from one point. It is as similar to a person stands in your class and he lectures. So he is a transmitter. He has certain messages to transmit, and obviously I should have someone to receive messages at the other end. So he is none other than the receiver. So now we are going to transmit our messages or signal from the transmitter to receiver. So here I need a medium to communicate my messages. So since it is wireless, we cannot go for a hard wire which connects the transmitter and then the receiver. So obviously, since it is a wireless channel, your air is going to act as a medium. So we are going to send our informations or signals through air. So that is why it is technically, we call it as wireless channels. So we will see much more about wireless channels and their characteristics in the upcoming videos, but as of now just assume that the medium that is used to transmit messages from transmitter to receiver here in wireless communication is the wireless channel that we use. So the signal that is very much suitable for sending over the air is the electromagnetic signal, and all the informations will take the form of electromagnetic waves. With this basic requirements, and these are all the very few components that is involved in wireless communication, and as I already said, I have assumed that the message is already generated and it is ready to transmit. All the pre-processing such as modulation, encoding, everything have been done, the message is ready to transmit. So now let us get into the basic terms which you will come across very often when we see wireless communication, and we will try to define what it is, and then we will see each and every topic with an example. So first thing which you will often come across is something called as propagation, and few terms that is very close to propagations are what are the modes of propagation, multipath propagation, and one familiar term we used to come across is fading, and then finally shadowing. So these are all the various terms which very commonly you will come across. So it is very much mandatory to understand what exactly all these terms are. So once we are very much clear with all these terms and principles behind these terms, it will be very easy to understand the upcoming videos which is relevant to wireless communications, and most exactly the path laws as well. So propagation of radio waves. So first of all, we start off with propagation. What is propagation? So propagation is nothing but the tendency of radio waves to travel from one point to another point in various parts of the atmosphere. Yes, of course, the tendency of my radio signals to travel from one point to other point is what we call it as propagation. And now we should have a question that how is my signal getting propagated when having air as the medium? So to answer that, there are different modes of propagation in radio waves. The radiated signal from the transmitter reaches the receiver in three different modes. So let's see what are they. The first mode is direct propagation. So here in this direct propagation, we could see that this is my transmitter and this is my receiver. So when you could see in case of direct propagation, my signal reaches the receiver without any reflection or without any diffraction or scattering anything. It is what something we call it as line of sight propagation. So when you have a clear line of sight between the transmitter and as well as the receiver, then your signal will directly propagate to the receiver side. So this mode of propagation is what we refer to as direct propagation. And then the second mode of propagation is ground wave propagation. So here is ground wave propagation. When ground wave propagation happens when there is a considerable distance between the transmitter and then the receiver. So when the distance between this transmitter and receiver increased, and due to the curvature nature of the spherical nature of the earth, we could not able to get the line of sight between the transmitter and then the receiver. So in such cases, we will rely on the ground propagation, and most of the EM signals will get reflected back when they hits the ground. So ground is in dielectric medium, so much more concepts are involved in understanding how the ground how the ground reflects the EM wave. So we will see all these concepts in the later on videos. So as of now, you just understand that this is one among the propagation mechanism. And the next mechanism is skywave propagation. Yes, even so this dotted line represents the ionosphere layer of your atmosphere. So this ionosphere layer, as you have already studied in your schooling, this is completely filled of charged particles, and since our signal is electromagnetic waves, it is going to get reflected by the charged particles present in the ionosphere. So this reflection will direct our signal again back to the receiver, and of course this is not pointed communication, but it will randomly turns down the propagation to the earth. So these are all the three basic propagations of my radio waves. Now we will come to the most important part and then most important concepts of the propagation. We do something called as multipath propagation. So as the name suggests, it has a direct meaning that we are going to propagate in multiple paths, but we should understand why is this multipath propagation happening. So to understand this, let us have an plane surface, and you have a transmitter at one end and you have a receiver at the other end. So in this scenario, when the transmitter radiates the messages, and the transmitter radiates, since there is no obstacle and this is an plain ground, you could see that the signal radiated from the transmitter directly reaches the receiver without any trouble. So here we follow the line of sight propagation or the direct propagation as we discussed in the previous slide. But unfortunately, most of the practical situations, this line of sight signal is not possible because there will be quite a lot of obstacle. The obstacle may be a building, or it may be a vehicle running on road, or even the lamp post that is installed on the roadsides. So these obstacles will obviously obstruct the line of sight propagation between the transmitter and then the receiver. So in these cases, multipath propagation will happen. Like how? When the transmitter radiates the signal will get reflected back over here, and not only the directed path. So each and every signal or every radiation that hits an obstacle will be reflected back, and then it reaches the particular receiver. So this scenario is what something we call it as multipath propagations, as the particular receiver receives the signal from various paths, means various versions of signal is received from different paths. So that is why it is termed as multipath propagation. So there are two important things that you have to notice or you have to remember when we are dealing with multipath propagation. Whenever the signal hits a particular surface, there are two important changes occurs in the signal. The first one is it will lose certain energy. The power of the signal will be attenuated to a certain level. Depends upon the surface and depends upon the power of the signal. My signal will lose certain amount of energy. So that is the first point which you have to consider, and that leads to the degradation of signal energy. And the second point, whenever my signal hits a particular area, the phase of that particular signal is going to get changed. So these are all the 2 points which you have to consider when dealing with multipath propagation. So more number of reflections, which means the signal is getting more attenuated, it has lost much more of energy, and then while reaching the receiver it will have only a little bit of power, which means it will be weaker. And then the phase of the signal is also the phase of this particular wave and the phase of this particular wave will be different. So each and every time it hits an obstacle, the phase is going to get changed. So now let us, so these are all the two things which you have to consider when we are dealing with multipath propagation. So now what are all the effects due to this multipath propagation? So putting into constructive and destructive scenario, there are two types of effects that we can have. One is the constructive scenario. So let us assume that this is what the first signal that I received at the receiver, and this is the second signal that I received at the receiver. Let us consider this as path 1 and let us consider this as path 2. So when these two, you can observe that these two signals are in phase each other, in phase to each other. They both have the same phase. So when they have the same phase, a typical receiver could not able to identify or differentiate which is a multipath signal or it is an interference. So simply an ideal receiver will adds up all the multipaths that is received at the receiver end. So when we add up these two signals, then since these two signals are in phase to each other, it will get stronger. So this scenario is what we have it as constructive scenario, so that a natural boost up for your signal will always happen in this constructive scenario. But on the other hand, we have the destructive scenario as well. So the destructive scenario occurs when the two path of signal are out of phase to each other. So you can clearly observe that these two signals are out of phase. So when my receiver simply adds up these two signals, then you know that my signals will get cancelled out each other and I'm not going to get any signal at the receiver side. So a typical receiver will just adds up all the multipath components so that you can end up in constructive scenario or destructive scenario. That is purely depends upon the phase change of each and every multipath component. So this is all about multipath propagation. So now let us come to a very important term, that is fading. So before getting into technical context of fading, let us see fading with some real-time examples which we have already come across in our day-to-day life, and we will try to correlate the example with the technical things. I think that must be easy to understand the concept. So generally, what do you mean by fading? So fading is generally referred to as the gradual loss of any quantity or certain quantity or parameter. So gradual loss of certain parameter which merely disappears over a period of time. So in order to understand this even better, let me take an example that we use in our daily life, that is our jeans pant. So whenever you buy a new jean, and not a faded jean, a proper jean, you could see the rich color of that particular fabric. The fabric feels too good, and as well as the color will also be so rich. And eventually when the days goes on, you could see that the same jeans pant could able to lose its color, so it will get faded. Yes, exactly. So this particular context or this particular concept is what we call it as fading. This we have seen in our day-to-day life, so there is nothing doubt in this. So how is this happening? So this parameter of the gradual loss of certain quality, here the quality or parameter, here the parameter what we consider is the color of the fabric. So when you notice the color of the fabric, you could see that the color of the fabric is eventually fading. It will be getting lighter, it will be getting light, it will be getting lighter, and by the days goes on, you will have a different color which is entirely different from the day one that you bought the pant. So what could be the reason? So there is no only one single reason for this fading to occur. There are quite a lots of reasons, such as the hardness of the water. So whether you are washing your cloth in hard water or soft water, that will contribute towards the fading. And where you dry your clothes, either in a shadow or on a sunny area, so all these things will contribute. And similarly, at what temperature of water you are washing your pants, so that is the another contribution. And importantly, what detergent that you use, the hardness of the detergent will also contribute towards the fading of the pant. So these are all the various variables or various reasons which contributes in the fading part. So I hope you now understood what exactly the fading is. Now let us try to put this concept in the technical terms. So in order to understand fading over here, the technical definition of fading is the variation of the attenuation of signal. As you all know that the signal will get attenuated whenever it travels a long distance or it is getting hitted on certain material. So this variation is what we call it as the fading. And the variables, which means the contributors of this particular fading, is it may be time, so your signal may get faded over time, and it can be geographical position, which means the distance as well, and similarly the frequency what you are using. So these are all the various variables, or I could say the different contributors for fading. And in wireless systems, the fading either will be due to multipath propagation or weather, particularly line. So let us see one by one. So here the first one is when you see, so this is what we something call it as path loss. So path loss is nothing but, so let us consider the first one, the blue one. You could see there is a transmitter over here, and then the receiver is placed very nearby to the transmitter, so that you will get a very good signal strength at the receiver. The signal is not going to get attenuated anyhow, since the distance is very low. However, when the distance between the transmitter and then the receiver is increased, you could see there is a significant drop in the signal strength. And when the distance is getting further increased, then obviously the signal strength will be lesser. So this scenario you can obviously observe in the classroom environment as well. When the teacher speaks from the stage, the people sitting at the first row will hear at a louder noise, and the people sitting at the back will able to hear only at an reduced level. So because there are quite a lots of attenuation factors in the hall, the fan, the noise at the corridor, and the people murmuring sound, all these factors will be attenuating my signal. So this is what something we call it as path loss. And a few more other contributors are the rain parameters. So the rain parameters, you could have observed that when it is raining heavily outside, you could not able to enjoy your TV shows if you are using DTS at your home. So all the EM waves will be absorbed by the water droplets in the atmosphere. So the rain will heavily affect the transmission of EM waves. So rain is one among the factor, and similarly the frequency that you use will also fade. So the low frequency signal or high frequency signal, depending upon the low or high frequency signal, your signal may get faded accordingly. And some other contributors are obstacles, which we have already seen in the multipath propagation slides. So when your signal is getting reflected multiple number of times, then obviously for each and every reflection your signal is going to lose certain amount, and that will eventually lead to fading. So this entirely is what we call it as fading. And that's not all, but fading, there are quite a lots of types of fading available, depends upon the environment, depends upon the times, which we will take it further in the next video. But as of now, we will see what are all the types of fading available in this video. So fading is broadly classified into two types. One is small scale fading and another one is large scale fading. And the small scale fading is further divided into two types. One is multipath delay spread, and the other side we have Doppler spread. So large scale fading is again divided into path loss and as well as the shadowing. So here the path loss, which we have already seen, which means that the attenuation of signal will get increased when the distance between the transmitter and receiver is getting increased. In some of the literature, the distance between transmitter and receiver is referred to as the separation, the transmitter receiver separation as well. Shadowing we will see in the next particular slide, and we will end that concept over here. But this is not all. We have some more types of fadings as well. The multipath delay spread fading is divided into flat fading and as well as frequency selective fading, whereas the Doppler spread is divided into flat fading and as well as fast fading and then slow fading. So these are all the types of fading that is available or which can occur on the particular signal. So we will see each and every fading in detail in the upcoming videos, but as of now just understand or just get to know that these are all the types of fading that is available on the signal. So next term that we are going to cover is shadowing, so which is the last topic in this particular video. So shadowing is nothing but, technically, shadowing is the effect the received signal power fluctuates. So whenever is received signal power fluctuates because of any obstacle that is obstructing the propagation path, obstruction path between transmitter and then the receiver, is what we call it as shadowing. So to understand the concept, let's just pictorize this. We have a transmitter over here, and then we will have an obstacle, and then we have a receiver over here. So obviously let us consider that he is standing at a point A, and we will eventually consider the user is moving in this direction. So I have taken the each and every point as A, B, C and D. Now let's try to measure the signal power, the received signal strength when the user is at point A, and when the user is at point B, when the user is at point C, and similarly when the user is at point C. So what happens is, when the transmitter radiates a particular signal, see, when the user is at point A, there is no obstacle between the transmitter and then the receiver, so that the receiver could able to get good signal strength when he is at point A. And similarly, when the user moves a certain distance and when he is between the point B and C, the signal strength that he is going to get is going to greatly affect by the obstacle present in between the transmitter and then the receiver over here. So that my receiver could able to still get the signal, but with a reduced signal strength. The signal strength will not be as strong as when he is at point A. So when he further moves down to point D, then again the signal strength will be increased. So when we put this scenario on a graph like this, taking position on the x-axis and received power at the y-axis, we could see that when the user is at point A, he could able to receive high signal power, and then when he is at point B and C, he could able to receive only less signal power, and when he reaches point D, the signal power is again getting increased. So this particular fluctuation, so there is an increase in signal power and there is a sudden decrease in signal power, and similarly again there is an increase in the signal power. So this fluctuation of the signal power is because of this particular fluctuation, is because of this particular obstacle that is present between the transmitter and then the receiver. So this concept is what we call it as shadowing concept. So that's all about today's video, and I hope you have enjoyed this video. So if you like this video, do press the like button. If you unlike the video, do press the unlike button and subscribe for much more videos on this video. So thank you.